This video is a 95 question Algebra 1 midterm review. Number 1 is written in function notation. When they say h of -2, that means you plug in -2 for x. So we use substitution where we put parentheses, and this is now 2 times -2 instead of 2 times x, which gives us -4. Add 1, -3. For number 2, we replace y with what it's equal to in the other equation. So what used to say y equals 2x plus 35 now says 9x equals 2x plus 35. This is a two-step equation. Subtract 2x from both sides to get x only on the left. Divide by whatever's in front of x, which is 7, to get x equals 5. Replace x in the top equation with what it's equal to in the bottom equation. So instead of -8 times x, we have -8 times -2y, minus y equals 30. So first we do this multiplication to get positive 16y. Then we combine like terms. This is a 1. That gives us 15y is equal to 30. We divide by whatever's in front of the variable. Y equals 2. Replace x in the second equation with what it's equal to in the top equation. So I plug in -5y minus 10 plus 9y equals -2. I combine like terms. See here it's the -5y and the positive 9y. That combines to give me 4y. Now I'm looking at a two-step equation. I add 10 to both sides. I divide by whatever's in front of my letter. I get y equals 2. This would be a lot of work for substitution. Instead, we use a process called elimination. The way elimination works is you add all of the columns straight up and down. It works really well when you have the same number where one is positive, one is negative. 5x plus a -5x cancels out. 10 minus 1 is 9y. -5 plus 32 is 27. To find out what 1y is, we divide both sides by 9. Y equals 3. Number 6 is not quite set up for elimination. X's both have a coefficient of 5. But is one positive and one negative? No. So what we can do is multiply one of the equations by -1. I chose the bottom one. So I take a -1, I distribute to each of the terms on both sides of the equal sign. So this I could cross out now if I wanted to. It's been replaced with -5x plus 4y equals 24. Now I can add straight up and down. The x's cancel out. I have 4 plus 1 is 5y. There's a 1y here. -19 plus 24 is 5. Divide both sides by 5. I get y equals 1. 7, to set it up for elimination. Does 2 go into 5? No. Does 3 go into 9? Yes. So I'm going to triple this entire bottom equation. Now that I've done so, I can scribble this out so I am not confused. 9 plus -9 goes away. I would cross that part out. 2 plus 15 gives me 17y. 49 minus 15 gives me 34. Last step, divide both sides by 17, y equals 2. This one is not set up for elimination, but 2 goes into 4, and 1 goes into 4 also. I chose to scale the x's, so I didn't just multiply by 2, because then I would have 4 and 4. I multiplied by -2, so I have 4 and -4. So after I multiply everything in this entire equation by a -2, I'm going to scribble it out, and I'm going to add straight down. The x's are canceled out. I have -1 plus 8, that's 7. 11 plus 52, that's 63. Divide by the number in front of y equals 9. Number 9, first I rewrote this so that 3x plus 3y equals 9 is underneath the other one. It's all lined up. I have an x column, a y column, and a numbers column. 3 does not go into 7. 3 does not go into 8. So I have to scale both equations. I take the top one times 3 and the bottom one times -7. So I multiply everything by 3 to get this. I multiply everything by -7 to get this. I know I did something right because I have the same number, 1 plus, 1 minus. So this way, if I add straight up and down, the x terms cancel out. And then I have 24 minus 21, which is 3y. 57 minus 63, which is -6. Divide by whatever's in front of y equals -2. For a number of solution problems, I'm going to start by using elimination. This is already set up. I'm going to add. On the left, both of these cancel out, so I can just put a 0. And on the right, -5 plus 3 is -2. Is 0 equal to -2? No, that's false, so I pick no solutions. Next up, this one's not set up for elimination. 6 does not go into 9, but 5 does go into 10. So I take this top equation and I double the whole thing. So I'm going to rewrite it down here after I've doubled everything. So let's scribble this one out. And now I'm going to add straight up and down. And I can see that the y's are going to be eliminated. And then I have 9 minus 12 is negative 3x, and negative 19 plus 18 is negative 1. Now at this point, I could keep going and find the answer. But if I don't have the case where both letters cross out, I just pick one solution. I'm done right here. Again, if both of the letters cancel out, it's either A or B here. But since I still have this x, one solution. Number 12 was not set up for elimination, but if I double this top one, I'll have the same numbers. And if I multiply by negative 2, I'll have the same numbers, but one positive and one negative. So after I multiply everything by negative 2, I rewrote that down below. That's here. I'm going to add straight up and down. The x's go away, the y's go away. 1 plus 2 is 3. 0 is not equal to 3. False, no solutions. 14 is already set up for elimination. Add, add, add. And this one cancels out, and cancels out. What's left is 0 is equal to 0, which is true. I pick infinitely many solutions. This is the product rule. If you have the same base, you can add the exponents. 6 plus 1 is 7. If you have the same base and you're multiplying, you add the exponents. 5 plus 6 is 11. Same base and you're multiplying, add the exponents. 3 plus 4 is 7. 5 plus 6 is 11. This one looks a lot more complicated, but it's really the same idea once we break it down into parts. 16 times 14, numbers times numbers. I wrote that here. The x to the fifth and the x squared go together right here. Y to the fourth and y squared goes together right here. 16 times 14, I can actually get an answer, 224. For these, I add the exponents. 5 plus 2 is x to the seventh. 4 plus 2 is y to the sixth. Let's again group these. All the numbers go over here. There's only one. The x's go together right here. The y's go together right here. 16 comes down. 2 plus 3, x to the fifth. 3 plus 4, y to the seventh. This is the quotient rule. Same base, but there's a fraction bar. Subtract. 7 minus 2 is 5. Same base with a fraction bar. This is the quotient rule. 5 minus 3 is 2. This is the quotient rule with multiple terms. I can split them up. Numbers divided by numbers, x's divided by x's, and y's divided by y's. On the left, I just get an answer. It's 1. 8 minus 7 is x to the first. I don't have to write the 1. 8 minus 1, there's an invisible one there, is 7. 24. Numbers divided by numbers, x's divided by x's, y's divided by y's. So let's look at them all separately. This part, I can just get an answer. It's 5. 5 minus 8 gives me negative 3. 7 minus 1 gives me 6. We don't really like to leave negative exponents here. Another way to rewrite them is to move them to the bottom of the fraction, and now they're positive, because negative exponents represent repeated division. 25 is the power to a power rule. We take 2 times 5, we get 10. Here this is 5 to the second power, all of that to the sixth power. So 2 times 6 is 12. 5 times 3 is 15. So watch for the parentheses, look for that exponent to a power of another exponent. R to the 6th times 2 is r to the 12th. For this one, it's almost like we distribute the exponent to each of the terms separately. So I kept them inside parentheses, negative 5, x squared, and y to the third, and I squared each of them. Be careful with this one. The negatives actually cancel out, and I get positive 25. 2 times 2 is 4. 3 times 2 is 6. Same thing with number 30. I separate the pieces and I square each of them. It's almost like I'm distributing that 2 to each term. So this is negative 3 squared, which is positive 9. X squared squared, 2 times 2 is 4. Y squared, 1 times 2 is 2. 31, I start dealing with fraction and negative exponents. And when you have a 0 as an exponent. Here I use the product rule. 4 plus negative 4, or 4 minus 4, gives me 6 to the 0. Anything raised to the power of 0 is just 1. C. This one wants to know what will the exponent be if I use the product rule. The product rule says add the exponent. So I take 1/5 plus 4. On your calculator, you can always press alpha x, and that opens up the fractions. So you don't have to know things about common denominators. Your answer is just 21/5. This is the quotient rule. 5 to the negative 1 divided by 5 to the negative 2 means I subtract. So negative 1 minus a negative 2, which is really the same thing as negative 1 plus 2. Minus negative turns into plus, which means the answer is 5 to the first, which is just 5. Quotient rule, 2 minus 2/3 is my new exponent. Do that in the calculator, you get 4/3. This is the power rule. Negative 1 times 4. That's negative 4. Sometimes the answer will be left like that. To express this as a positive exponent, we have to move it to the bottom of the fraction, because negative exponents represent repeated division. And that's the answer here, letter B. The power rule, 3/2 times 6. Do that in your calculator, you get 9. For fraction exponents, we are going to write the power on the top and the root on the bottom of the fraction. So we are not really doing any math, we're just rearranging. This becomes the second root of 49 to the third power. This one becomes the second root of 64 to the first power. Notice, the second root is the default root. So sometimes we just say square root, and that means there's a 2 there. And we don't always have to write the 1. I would accept either of these for full credit. If you tried to write 8, it would be wrong, because 8 is not in radical form. X to the 1/5 is the same as the fifth root of x to the first. X to the 1/4 is the same as the fourth root of x to the first. Working backwards, the second root of x to the 5th can be turned into x to the 5/2. The sixth root of x, there's an invisible 1 here for my exponent. So this becomes x to the 1/6. For 43, first, I use the product rule. Negative 7 plus 6 is negative 1. That's my top. Then I know that 0 exponents will just give me 1. So 2 to the negative 1 over 1 is the same thing as just 2 to the negative 1. C. If that wasn't an answer choice, we could think of 2 to the negative 1 rewritten, where 2 to the negative 1 goes to the bottom as 2 to the positive 1, or 1/2. But you didn't have to do that for 43. For 44, 5 to the 0 is just 1. And this part is the quotient rule. 5 to the negative 5 minus 5, which gives me 5 to the negative 10. So 1 times anything is anything. So 1 times 5 to the negative 10 is 5 to the negative 10, which is C. First thing I do is this part here on the left. I can use the power rule to say negative 3 times 0, which is just 0. Then I use the product rule to take 0 plus negative 2, and that gives me negative 2. Another way to write that is 1 over 2 to the positive 2, because negative exponents, when you move them to the bottom of the fraction, become positive. Another way of writing this, well, 2 squared is 4. So my answer is D, 1/4. 46, I begin inside the parentheses with the product rule. 1 plus negative 6, or 1 minus 6, is negative 5. Then I use the power rule. Negative 5 to the 5th is negative 5 times 5, which gives me negative 25. D. For 47, I start on the top of the fraction. The power rule says I can take 0 times negative 2, and that just gives me 0. Then I'm going to use the quotient rule. 0 minus a negative 2. Minus a negative 2 is like plus 2. So this is like 6 squared. Another way to write 6 squared is 36. Choose B. 48, I start in the parentheses. I use the quotient rule. This is negative 1 minus a negative 2. That's like doing plus 2, so I get 3 to the first. Then I use the power rule to take 1 times negative 1. And the answer is 3 to the negative 1, which can also be written as 1 over 3 to the positive 1, or 1/3. 49, I distribute, which means I take the outside number and multiply it by each inside term. 3 times 2 is 6, 3 times 9 is 27, and you bring down the x. Negative 3 times 1 is negative 3. Negative 3 times 1 is negative 3, and you bring down the x squared. there's a 1 in front of x squared. 5 times 2 is 10, and you add up these exponents using the product rule. So 1 plus 1 is 2, or x times x gives you x squared. 5 times negative 9 is negative 45. There's only one x, you bring it down. 52, combine like terms. The ones in blue I'm going to do first because we always put our biggest exponents first. I combine the 3 and the 1 to get 4x squared. Because I'm adding, my exponents do not change. Earlier I was multiplying. Different story. Negative 4 minus 2 can be combined to negative 6. I'm going to do the blue terms first. Negative 3 minus 2 is negative 5 because I'm adding and subtracting. The exponents do not change. There's only one x term, 2x, so I just bring it down. 54 is polynomial addition. I can almost ignore the parentheses when there's addition, and I just look at blue and blue. These are x terms. Negative 6 plus 3 is minus 3. The x's don't change when you're adding and subtracting. 2 minus 6, negative 4. For 55, I'm going to start with the biggest exponent. These are the x squareds. The exponents do not change. I just take 9 plus 2 is 11x squared. My next biggest degree is just the x by itself, and there's only one x term, so I carry it down. Lastly, I have the constants, or the numbers. Negative 2 minus 5 is negative 7. 56 is different, because this is polynomial subtraction. So we cannot proceed the same. Instead, we have to distribute this negative first. So think of that as negative 1, and it takes what was positive and makes it negative. But I also have to take negative 7x and make it plus 7x. On the left, I don't do any of that. Everything is copied down exactly as it was written. Now I consider like terms. X squareds first. 6 minus 3 is 3x squared. Next up are the x terms. Negative 3 plus 7 is 4x. And you bring down the 7. 57 requires substituting for b what b is equal to, negative 2t plus 1. And substituting for a what a is equal to, t plus 9. So that's the first thing I do is I write the setup. The second thing I do is I distribute the 2 to both of these sets of parentheses. If I distribute correctly, I get 2 times negative 2 is negative 4t, 2 times 1 is 2, 2 times t is 2t, 2 times 9 is 18. Lastly, combine like terms. Negative 4 plus 2 is negative 2t. 2 plus 18 is 20. 58, I take 2 times this expression, y plus 5, and I subtract from that this entire expression, y squared minus y minus 9. So the setup is key. I will distribute my 2. I get 2y plus 10. Don't forget that it's 2 times 5 also. And I distribute this like it's a negative 1. So negative 1 times y squared, negative 1 times negative y, which turns into positive, negative 1 times negative 9, which turns into positive. Next up, I just combine like terms. I do the y squareds first. There's only one. I bring it down. I see 2y plus 1y is 3y. 10 plus 9 is 19. 59, I am distributing negative 3x squared to each term inside the parentheses. First, negative 3 times 2 is negative 6. I use the product rule to add the exponents because I'm multiplying. 2 plus 2 is 4. Negative 3 times 1 is negative 3. I use the product rule to add the exponents. 2 plus 1 is 3. Negative 3 times negative 7 is positive 21, and I bring down the x squared. 60 is polynomial addition, so I can almost ignore the parentheses. I have 6x squared as my only x squared term. Next up, I have negative 6x and minus 5x. They go together as negative 11x. Negative 2 and negative 10 combine to negative 12. Next up, I'm going to do the box method. So I take 2x and 6 and write them along here, and x and minus 6 and write them along the left. For the inside parts of the box, I do row times column. That means 2 times 1 is 2, and I use the product rule to add up my exponents. 1 plus 1 is 2, so it's x squared. Then I take 2 times negative 6, that gives me negative 12, and I bring down the x. This one is 1x, so that's 1 times 6 is 6, bring over the x. Negative 6 times 6 is negative 36. I will always combine like terms on this diagonal. So the 2x squared comes down. I have negative 12 plus 6, which is negative 6. And then I have negative 36 here. This is my final answer. 62 is polynomial subtraction, so I can treat this like a -1 and distribute to each term on the right. The left just copies down, but the right, it's the opposite. Instead of -x squared, it's positive x squared. Instead of 3x, it's -3x. Instead of -6, it's positive 6. Then I combine like terms. X squareds, I have 2 and 1, which gives me 3. For x's, I only see this one, so I bring it down. And then for numbers, I have -4 plus 6, which is 2. When there is a binomial squared, it's the same thing as multiplying by the same numbers twice. So x and 7, x and 7. This gives me x squared, 7x, 7x, and 49. I combine like terms along the diagonal, so 7x plus 7x is 14x. And this down here is my final answer. The trinomial means I have 3 terms, 1, 2, 3. Standard form means I start with x squared, then x, then numbers. 64, I'm plugging in, so 2 times x squared plus 2, and then plus 2 plus 2x squared. So I'm going to distribute this 2, and then I'm going to combine like terms. So I have 2 plus 2 is 4x squared, 4 plus 2 is 6. Number 65 has a couple of different steps. I wrote them over here. First thing we do is the box method. Then we distribute, then we combine like terms. So the box method shows up right here. Do you see where it says x plus 4 squared? So I'm going to do that over here on the side. I have x and 4 and x and 4. X times x is x squared. This is 4x. This is 4x. This is 16. Combine like terms. The 4x and the 4x give me 8x. And I'm going to replace that right here. Everything else in this problem, I rewrote it exactly as it was. 2, but instead of x plus 4 squared, I have this trinomial. You'll notice that this was all just copied down. So that's step 1. I am done. Next up, I distribute. 2 times all of these, rewrite it. 5 times these, rewrite it. Don't forget to bring down the plus 5. Finally, I combine like terms. I start by looking for my x squared terms. There's only one. Let's bring it down. I see a 16x and a 5x. Add them together, 21x. 32, 20, and 5 combine to give me 57. Same method here for 66. Start with this part, use the box method, replace it. Then I distribute the 3 and the -5, rewrite everything. Combine like terms. There's only one x squared term. I combine these 2 x terms, and I combine these 3 number terms. 67 is the same way. Box method here. There's no distributing to do on the left, but I do distribute the 5, and I bring everything down, and I combine like terms. X squared is the only x squared term. 4x and 5x become 9x, and there's 3 different numbers that add up to 18. 68 is the same type of problem. I start with the box method, I get this, I plug it in, I distribute my -3, I rewrite everything, I combine like terms. X squared comes down, -8 and -3 is -11x. 3 different numbers combine to give me 34. 69 is classic box method. So we write x and 2 and x and 6. X times x is x squared. X times 2 is 2x. 6 times x is 6x. 6 times 2 is 12. I combine like terms on this diagonal. They give me 8x. Everything else is pretty much as it's written. This is my final answer. Number 70, I set up my box method, and I have x minus 6 on the top and x minus 6 on the left. X times x times -6. -6 times -6, remember that comes out positive. I combine like terms on this diagonal, giving me that -12x, and this is my final answer. 71, I set up the box method, 3x minus 2, 2x and 2, multiply rows by columns. I combine like terms here on the diagonal. It combines to a positive 2x, and this is my final answer. For 72, x plus 4 squared is the same as x plus 4 times x plus 4. So when I use the box method, x and 4, and then when I combine like terms, these will combine to give me that 8x. 73 is similar. X minus 11 squared means x minus 11 times x minus 11. Set up on the sides for the box method, x times x times -11, Negative 11 times x, negative 11 times negative 11 turns out to be positive. I combine like terms here on the diagonal. That gives me negative 22x, and this should be plus 121. 74 is similar, but it's larger, so I have a binomial here on the left times a trinomial here on the top. So I still do rows times columns. I have to pay close attention to negatives. Remember that since I'm multiplying, I add the exponents. 1 plus 2 gives me 3, and so on and so forth. I will still combine like terms on the diagonals, meaning that the negative 3x cubed just carries over, so does the 5, but these parts combined give me negative 13 and negative 5. For 75, I do the box method first. Let's do that over here. I get this, which I can replace. The next thing I do is I distribute the 3, and I distribute the negative 4. I rewrite everything. At this point, I combine like terms. That's the only x squared. I have 2 different x's, combine them. 3 different numbers, combine them. The calculator shortcut to find the greatest common factor of 2 different numbers is to press Math, right arrow, 9, and type in those 2 numbers separated by a comma. If you press enter, you'll get 6. You can also start with the smallest number and write down a list of factors. You're going to try to find the largest number that also goes into 42. 30 does not, 15 does not, 10 does not, but 6 goes evenly into 42. You don't get a decimal. There is your GCF, it's 6. The calculator shortcut works again. I can also start with a smaller number, 18, and think about a list of factors. 18 does not go into 27, but 9 does. It's the biggest one that does. When we have 3, the calculator trick doesn't quite work because you can only pick 2 of them. Our advice there is to choose the smallest number and one of the others and just test to make sure that it still goes into the third. You can also just try the smallest number. So the smallest number is 10. Does 10 go evenly into all of these? Yes. So that's the GCF. Here's that trick again in 79. 6 is the smallest number. It goes evenly into all 3. There's our GCF. The smallest number is 20, which does not go into 30. So that one I would cross out. The next biggest factor is 10. 10 evenly goes into all of the others, so there's my GCF. If I was doing this on the calculator, I might type math, right, 9, and I might put in 20, 30, or 20, 40. Just make sure you are including that smaller number. And you can also test, does my answer go into the other number? So I look at the numbers first, 24 and 48. Let's try the smaller number. Does 24 go evenly into both of these? Yes. So there's the number answer. Both of these have an A. Both of these have a Y. Do they both have a Z? No. So AY is part of the GCF, but Z is not. Try the smaller number. 10 goes evenly into 20. They don't both have a B, so my GCF is just 10. For 83, start with 30. Does it go into 45? Not evenly. Cross it out. Try the next biggest factor of 30. 15 goes into 45 evenly. This one has an A, this one has a B, this one has a whole different letter Y. So there's none in common, so I do not include them in my GCF. I just leave it as 15. 15 is a smaller number. It goes into both. There is not a common letter. The answer is 15. Number 85, I start with a smaller number, 21. 21 does not go evenly to 28. Cross it out. Next biggest factor is 7, which does go evenly into 28, so I'm going to include that. A is not showing up in both of these, but W is. I choose the smaller exponent. So 2 is the smaller exponent, and that's the one I use. They each have at least 2 W's. This one has more, but they have 2 in common. Next up, the X method. So I start with the top number 12, and I'm looking for factors of 12 that add up to 7. So possible factors of 12 are as follows. Which of them also add up to 7? These do. So I write the answers in the blank. If I want to double check my answer, I can always take 4 times 3. Do I get 12? 4 plus 3, do I get 7? I do, so I pick the right numbers. For 87, I start with the top, factors of 30. This is like 1 times 30, 2 times 15, 3 times 10, 5 times 6. Which of these add up to 11? It's these. Double check your answer, 6 and 5. Out of the factors of 40, 10 times 4 also add up to 14. It's always a good idea to try the number itself and 1. So for example, 8 is the number on the top. If I try 8 and 1, do they add up to 9? Do they multiply to give me 8? Yes. So try that first before you go looking for other numbers. Works again here in number 90. 4 times 1, 4 plus 1, so my answer is 4 and 1. 91 is unique because the top number is positive and the bottom number is negative. When that happens, your two answers will both be negative. For example, factors of 28 are numbers like 7 times 4, but 7 plus 4 does not add up to negative 11. So we have to make them both negative. Negative 7 and negative 4. When you multiply, you still get 28, and when you add, you get negative 11. 92 is back to 5 and 1. 5 times 1, 5 plus 1. Quick and simple. 93 has a negative on top. That's the first one like this. So we still look at factors of positive 54. Things like 1 times 54 and 2 times 27 and 3 times 18 and 6 times 9. But now, instead of adding to get to this bottom number, we want to subtract. And we don't care about the negative just yet. We're going to look to see which of these numbers subtracts to give us 25. And that's why I circled or boxed 2 and 27, because 27 minus 2 gives me 25. So the choice is, how do I know which one is negative? Well, guess and check. Does negative 27 plus 2 work? What about 27 minus 2? That one does not work. So the 27 has to be the negative one. And another one, we try 8 and 1. 8 times 1 and 8 plus 1 both work here. Final problem, 17 times 1, 17 plus 1. Thus concludes our Algebra 1 midterm review.